Welcome to the basic training Pneumatics and Process Interfaces.
My name is Tom and this is Lisa. We're your virtual trainers and we'll guide you through this training video. We'll run through some basic knowledge and sum up the most important points. After each part, you'll have the chance to check your knowledge by answering some questions.
In this training, you will learn general things about pneumatics and process interfaces, single valves for integrated mounting on the actuator, as well as valve blocks and valve islands with and without field bus interfaces in control cabinets. Pneumatic valves are used to control actuators with compressed air. They're found in various areas, in non-X as well as in hazardous areas. Pneumatics is used in 4 of the 6 Bürkert segments: hygienic processing, water treatment, steam, and cooling systems. Pneumatic valves and valve islands from Bürkert are particularly successful in process automation. The top-selling area is food and beverage automation, like breweries and dairies. First of all, an example from a brewery. Here we have a bottle filling plant. In the center, many classic process valves can be seen. These classic process valves are connected to the valve islands or automation systems with black pneumatic hoses. Raw milk is transported from the farms to the dairy, where it's continued to be processed to different products. Here we see a part of a dairy plant. In the center is a stainless steel control cabinet with lots of electronics and a Bürkert valve island type 8640. In the background, the heat exchangers constantly cool the processed milk. Another important area using pneumatics is water treatment. A Bürkert service engineer installs an airline system type 8644. The entire installation is in a municipal waterworks. High demands for process safety are a key factor in the pharma industry. Mostly, these are hazardous areas where products need to have special features, like our Airline X Type 8650 for the use in X Zone 1. Additional areas where pneumatics from Bürkert are used are, for example, the offshore industry, plant engineering, or the packaging industry. Before we go into the details of the Bürkert products, we take a look at some basics of pneumatics. What does the term pneumatics mean? Pneumatics deals with the study of movement and balanced state of air. The energy transfer medium is compressed air. The compressed air causes mechanical motion, for example, a movement of a pneumatic cylinder or the control of an actuator. Compared to the electrical energy, compressed air offers some advantages. Compressed air can be stored easily due to its compressibility in pressure tanks. Actuators controlled with compressed air are overpressure proof. The use in hazardous areas is possible without any problems. And compressed air doesn't cause lost heat in the actuator. An important part of pneumatic applications are multi-way valves. They allow the working fluid to pass through, to block it, or to change the flow direction. We'd like to understand the function of a pneumatic valve. Lisa will explain the used symbols for us.
Each switching position is illustrated by a square. This symbol represents a two-way valve, as it has two switching positions. The ports are represented by lines connected to the square. The port lines are connected to the switching position that is currently active. This valve is called a 3-2-way valve, where the 3 stands for the number of ports and the 2 for the number of switching positions. The flow paths of the valve, once connected, are represented by symbols inside the squares. The most common symbols are an arrow for an open flowway and a short bar for a blocked flowway. Actuation is also very important for valves. This valve has a return spring to keep it in a defined position when it is de-energized. In this state, the flow is blocked. On the left side of the valve, we can see the symbol for a solenoid coil. When it is energized, the valve is pushed to the right. The left switching position is now active, and ports 1 and 2 are connected. Port 3 is blocked. In the de-energized state, the pressure supply is not connected to the system, but is connected to the third port. As well as the 3 two-way valves, there are also 5 two-way valves. These valves have 5 ports and 2 switching positions. The symbol shows the port connections.
Now Lisa has explained some of the symbols used in pneumatics. We can turn to the Bürkert program for pneumatics and process interfaces. First of all, we take a look at the single valves. We'll start with the types 6518 and 6519. Type 6518 is a servo-assisted 3-2-way valve. This valve consists of a pilot valve type 6014 and a main valve, the so-called pneumatic amplifier. Type 6518 works without constant air use and controls single-acting actuators. The use of high-quality materials makes it possible to use this valve in outdoor areas and in chemical atmospheres. Type 6518 is, together with Type 6519, one model range. Type 6519 is the more universal valve and offers more functions. That's why we take a closer look at this type. We have the possibility to use the valve as 5-2 or as 3-2-way version. The valve is offered as a standard or as an X valve for the use in hazardous areas. Furthermore, Bürkert offers additional variants with connections and dimensions according to the international norm NAMUR. This allows an easy installation in the field directly on the actuator. In general, Type 6519 consists of a servo-assisted valve Type 6014 and the pneumatic amplifier. The housing consists of a piston, 2 diaphragms, various sealings, and 5 pneumatic connections. Moreover, we have a manual override and a position indicator. Now we see how the valve works. When power is turned off, the device is in normal position. The ports 1 and 2 are connected to each other, and ports 4 and 5 are also connected, allowing the venting of the actuator to the atmosphere. When current is applied, the plunger of the servo-assisted valve is lifted to the inside of the coil by the means of solenoid power. Now the spring is compressed, and compressed air can enter the main valve. The movement of the white piston, as shown in the animation, is performed by compressed air. By the movement of the piston, ports 1 and 4 are connected. Port 4 is in practice connected to an actuator, for example a process valve. Port 2 and 3 are also connected, which makes the venting of the valve possible. If the magnet is de-energized, the power of the spring causes the plunger to go back to its original position. Therefore, port 1 is again connected to port 2 and, respectively, port 4 to port 5. Lastly, we take a closer look at the manual override. To manually operate the valve, turn the manual override as far as it will go. By turning it 90 degrees to the right, the manual override will be locked. At the same time, the red position indicator shows and remains in this position when the valve is switched. The d.o.o version of Type 6519 looks similar to the standard version. Only the working ports are on the side of the valve body. This valve is delivered as a 5-2-way valve. Optionally, the valve can be turned into a 3-2-way version by turning the rotating disc. The function principle of the d.o.o version is identical to the standard version, so we'll simulate the function of the d.o.o valve directly mounted to the process valve. To mount it on a classic process valve, an adapter plate is mounted between process valve and d.o.o valve. Now, by means of compressed air, the process valve is actuated with a d.o.o valve. In the original state, port 2 of the d.o.o valve is connected with the upper connection of the process valve. Compressed air fills the upper chamber of the actuator. If the d.o.o valve switches, this chamber is vented via port 3 to the atmosphere. At the same time, compressed air gets into the process valve via port 4 and lifts the piston. Besides the d.o.o valves for direct mounting on the actuator, there are other pneumatic valves which are, due to their compact design, mainly mounted on valve blocks and valve islands. Types 6524 and 6525 belong to these kind of valves. Type 6524 as 3-2-way or double 3-2-way version, together with Type 6525 as 5-2-way version, is based on a flipper servo-assisted valve and a pneumatic seat valve. Both types allow a flow of 300 liters per minute, are equipped as a standard with a manual override, and enable the switching of high pressures combined with low power consumption and short switching times. The double 3-2-way version is a combination of two flipper valves with a pneumatic seat valve. This valve can either switch both 3-2-way functions at the same time, or each of the 3-2-way functions separately. The animation shows the different possibilities of the double 3-2-way valve. First, we'd like to show how the left 3-2-way function works. Compressed air is applied to channel 1, reaches the inside of the main valve, and is depending on both servo-assisted seats of the servo-assisted valves. If the left servo-assisted valve is switched, the compressed air can surpass the servo-assisted seat and lifts the left piston in the pneumatic amplifier against the power of the coil. By the lifting of the piston, a connection from channel 1 to channel 2 is possible. Channel 2 is the working port where, for example, a process valve can be connected to. Closing starts when the servo-assisted valve is switched off. The piston in the main valve goes back to the start position by the power of the spring. The compressed air is vented from channel 2 via the air outlet channel 3 to the atmosphere. Similar to this switching operation, the switching of the right 3-2-way function works as well as the switching at the same time of both 3-2-way functions. By looking at the function of the Type 6525 as a 5-2-way valve, we'll bring the part with single pilot valves to a close. This valve has 5 connection ports, like the double 3-2-way valve. The valve doesn't fulfill a double 3-2-way function, but serves as actuation for a double-acting actuator. Here you see the switching of a 5-2-way valve. The function principle is the same as for type 6524. Now, Tom and Lisa have prepared some questions.
Lisa, I have a question for you. What's the difference between the valve type 6518 and 6519 and the type 6524 and 6525?
The types 6518 and 6519 are single valves that are often mounted directly on the actuator. The type 6524 and 6525 are mainly used on valve blocks and valve islands due to their compact design.
That's correct. Now ask me a question.
Sure, Tom. Do you know which valve function the type 6519 Namur has?
The valve is delivered as a standard as 5-2-way version. Optionally, the valve can be converted into a 3-2-way valve by turning a rotating disc. Lisa, do you know what the typical task of a 5-2-way valve is?
Sure. 5-2-way valves can control double-acting actuators.
Bürkert offers not only pneumatic single valves, but also valve blocks. The valve block type 8640 is suitable for many various and complex control tasks due to its systematic modular construction. Different valve functions can be realized without a common electrical control on one block. The pneumatic valves on the block are connected individually to the control system. Each of these valves has the task to control a single or double-acting actuator. Now let's take a look how a valve block is constructed. At first, we see the left and right pneumatic supply. Both modules guarantee a common supply to the valves with compressed air and the venting. Here you see the pneumatic basic modules in different sizes. The 8-fold basic module and the 2-fold basic module, where the valves can be mounted later on. The pneumatic supply modules and the pneumatic basic modules are put together and connected to each other by a simple clicking action. Finally, the valves are mounted on the pneumatic basic modules. The assembly is quite simple and is completed with 2 screws. This eases the change of the valves later on. On one valve block, different valve functions can be mounted. 3-2-way valves are possible, as well as 5-2-way valves, or double 3-2-way valves. The different functions can be combined in any order on one block. Valve islands and automation systems are constructed in the same way as valve blocks. In contrast to these, they offer a common electrical actuation of the valves. Common connection, multi-pin or field bus interfaces, for example Profibus or Ethernet, may serve as the communication module. But what is a field bus? Tom will lead us through a short excursion into field bus techniques.
A field bus connects sensors and actuators within a plant to a control device so that they can communicate with each other. Since the 1980s, field bus technologies have grown to become standard within the market. Today, automation technologies are accepted universally to be of crucial importance. You could compare it to not having the internet at home. Here you can see an overview of the different field buses. Each of these bus systems has different characteristics, like communication speed, dimensions of the network, or the kind of communication. That's why they have different specialist application areas. With the following example, we'd like to show you how different devices communicate with each other within a field bus network. In this example, we're using Profibus. In the left corner you see a control system, which is connected via a cable to the illustrated Bürkert devices. A level sensor, a valve island, an automation system, and a process valve. The control system requests the current level data from the level sensor. The level sensor then replies 10 meters back to the control system. The control system asks each device, one after the other, for their particular state or measured value. Each respective device reports back by sending a message to the control system. After all devices have been polled, the cycle will start again from the beginning. By using a bus system, the state of the devices in a plant can be shown on a screen, and troubleshooting, for example in the case of a plant failure, is made easier. Additional advantages also include possible savings through less wiring effort, easier maintenance, and enlargement of the bus network.
Now let's go back to the Bürkert valve islands. At first we take a look at the construction. Until this point, the construction is the same as for the construction of the valve block. Altogether, 24 valve functions can be combined on the Type 8640 valve island. In the next step, the communication module, as well as the electrical basic module for the electrical power supply, are mounted. The electrical connection technology allows a field bus interface, common connection, or multi-pin interface. In the new layer, you can add digital feedback inputs. A valve island uses these digital feedback inputs, for example for the processing of sensor signals, and uses the pneumatic outputs for the control of single and double-acting actuators. During the last step, the valves are mounted on the pneumatic basic modules. Now that the valve island is completely assembled, we'll take a look at the function in combination with a single-acting element actuator. The valve island and actuator are connected to each other with pneumatic hoses. Compressed air is supplied by the right pneumatic supply module. When the pneumatic valve type 6524 on the valve island switches, compressed air gets from the respective pneumatic output on the valve island to the actuator. The pneumatic valve type 6524 on the valve island controls the process valve in this way. When the pneumatic valve switches off, no compressed air flows in the actuator. There, the piston returns to the initial state by the power of the spring, and the exhaust air in the actuator is vented via the valve island to the atmosphere. The function shown here could be used, for example, in a dairy. The valve island is mounted in a control cabinet, and the process valves operating the plant process the milk from one production step to the next. Different to the Type 8640, the airline system Type 8644 can not only process digital but also analog signals. Overall, Type 8644 offers more functionality concerning modularity, data processing, and field bus techniques. Altogether, up to 64 valve functions may be combined together on one airline system. Bürkert works together with 4 well-known I.O. producers: Siemens, Vago, Phoenix Contact, and Rockwell. Bürkert offers the pneumatic part, while our cooperation partners the field bus interfaces and the digital and analog I.O. modules. Our customers can choose if they want to have from Bürkert only the pneumatic part or the complete automation system with integrated field bus, I.O. modules and pneumatics. The pneumatic parts of the airline are constructed in a similar way as Type 8640. We'll take a look at the left supply module, which ensures both the pneumatic supply of the automation system and the interface to the I.O. modules of the cooperation partners. The pneumatic and electrical basic modules are connected to one unit and mounted together with the left and the right supply module. In the last step, the valves are mounted on the automation system. Via digital and analog input modules, sensor inputs are detected and accordingly controlled via digital and analog output modules, actuators, or complete decentralized control system. For example, flow, pressure, temperature level, or other chemical values. The pneumatic valves used on Type 8644 control single and double-acting actuators. In the 3D illustration of Type 8644, 5 two-way valves are incorporated and shown. As we've already learnt, a 5 two-way valve serves as a pilot for double-acting actuators. Now we look at how the combination with a double-acting element actuator works. In comparison to the previous seen Type 8640 with 3 two-way valves controlling an element single-acting actuator, here the return spring is missing. Both the resting position and the actuated position are operated by compressed air. There are some integrated process safety features for valve islands and automation systems like check valves integrated in the air outlet of the pneumatic valves and the pneumatic hot swap function, making it possible to change the valve while the system is running. These process safety characteristics are an important issue, especially in hygienic processing environments. Let's presume that a pneumatic valve on an automation system is damaged and has to be changed. At first, the valve is removed by loosening both fastening screws. By doing this, you see the pneumatic module with the integrated hot swap function. Only a small air jet can exhaust, meaning the air pressure on the entire block doesn't collapse. A new pneumatic valve can now be mounted on the empty valve space. The new valve is ready for operation immediately. Check valves ensure more safety in the process. If there's a failure in the plant, all actuators turn off at once. There, all the exhaust air needs to be vented to the atmosphere. In doing so, a back pressure in the valve can build up when the venting of the air doesn't happen fast enough. This back pressure can cause an accidental actuation of a valve, which may cause a lot of disruption within the process. If check valves are integrated within the basic modules, this potential problem can be avoided. As you've now seen the basics for pneumatics, pneumatic valves, valve islands and automation systems, we now take a look at control cabinets and Airline Quick. With Airline Quick, Bürkert has enlarged the product program of valve islands and automation systems with an adapter plate for the direct mounting on the control cabinet. Airline Quick is available for the valve island Type 8640 and the airline system Type 8644. How is Airline Quick constructed? At first, the valve island is connected to an adapter plate. Depending on the demand concerning durability and cleanability, you can use either an aluminium plate or a stainless steel plate. The pneumatic connections are screwed together between the adapter plate and the valve island. The connections are available in stainless steel or nickel-plated brass. Afterwards, Airline can be mounted easily on the control cabinet wall or the control cabinet floor. Lastly, a metal plate mounted on the outside of the control cabinet guarantees additional stability. The advantages of Airline Quick are the possibility to use a smaller and more reasonably priced control cabinet, easier assembly, and a shorter commissioning time. Moreover, in comparison to the conventional solution, you need less pneumatic hoses and cabinet screw connections. Finally, you now have the possibility to check your newly learned knowledge by answering some questions.
What's the difference between the valve block type 8640 and the valve island type 8640?
Well, the difference is that a valve island is not only a pneumatic solution, but also has a common electrical actuation system via a common electrical connection, field bus interface, or multi-pin. Furthermore, a valve island has the option of digital feedback inputs. Lisa, what's the pneumatic hot swap function?
The pneumatic hot swap function enables you to change the valve while the plant is still running. Tom, can you tell me what are the customer benefits of the Airline Quick?
Sure. Airline Quick enables easier assembly, shortened commissioning time, and the added benefit of being able to use a smaller control cabinet. Moreover, fewer components are needed, such as pneumatic hoses and cabinet screw connections, saving even more time and overall cost.
Well, that wasn't too difficult, was it? Please do watch the video again if some passages were too fast, or take a look at the product overview for pneumatics and process interfaces. If you'd like to configure valve blocks or valve islands, then you can use our online configurators, which supply you with the desired configuration and deliver a bill of material, descriptions, 3D modules and prices. If you have any questions, please send an email to the following address: technical.training@bürkert.com. Thank you very much for your interest.